What's going on, arcade nerds? Last few days I've been really sick, and I've pretty much been moping around the house, making sick noises and stuff like that. But as I said, I was originally not even going to do this video because I was kind of just feeling sick, moping around the house. But you see, I bought an Asteroids machine, another one, and I decided to make it my weekend project. And so this is what I did. I colorized me and a friend, a friend of mine from Finland, I believe, Sanduli. We did this, and I want to show you guys how it works. And it's way better than a past Asteroids color mod that someone else did, and this is completely 100% programmable and so on. But let me explain how it works first. If you want to see what it looks like, skip to the end of the video. But if you want to sit here and learn something, maybe watch this. What I'm about to do. Anyways, in the original schematics for Asteroids, you have a resistor DAC, okay, and that resistor DAC is all connecting together, and going through another resistor here. This would be your ground, and going through another resistor here. This would be your 5-volt. Okay, now these resistors are different sizes. Okay, now binary code, zeros and ones, will either turn these wires on or off. But since it's TTL, it can only be one of two states, on or off. So 5 volts ish or 0 volts. Okay, and that's where these resistors come into play. These are different size resistors, so depending on the combination of these ones and zeros, it will come out here and go into a transistor and so on at different voltages. Okay, so the different voltages act as your Z intensity. Now when I say Z intensity, what I'm talking about is when vectors are drawn on your screen, it's kind of like drawing with a pencil. Okay, but let's say you have a button on your pencil, and when the button is pressed it draws, and when the button is released it does not. That's kind of how vectors are drawn. Okay, and the Z intensity is how bright that vector is going to be. Okay, what we're going to do is similar to the old mod, but different. Okay, the old mod had you tapping off of each of these intensities and going through a series of transistors, and to be honest, I don't even think it would have worked properly because they had a very weak blanking circuit. There's supposed to be a blanking circuit. A blanking circuit, what it does is it turns off the Z signal. Okay, so what I did in my mod is, instead of these resistors right here, what I did is, by the way, these wires are going to be labeled 0, 1. You know what? Let me do it backwards because that's how I have it in my mind. I have it backwards. Let's go 3, 2, 1, 0. Okay. Now I'll get to why these numbers are important in a minute. But instead of having them go through different size resistors, what I did is I had them go to diodes. Now these diodes are 1N4148 switching diodes. Nothing more fancy than that. Okay, simple, common, easy to find. Those are all going to that same ground, and eventually it's going to go to a transistor to be amplified. Okay. I got a cough. But so instead of it, so now with this setup, if there is ever a 1, we basically made an OR gate. If there is ever a 1 on any of these pins, then Z will be on. Okay. Now, what I did is with that, so what this did is it removed all intensities. All intensities are now gone. If there's a vector to ever be drawn that is supposed to have any intensity at all, is 100% intensity, all intensity, going to Z. Okay. Now keep that in mind. Now this is still your normal Z output on your PCB. On an Asteroids circuit board, it will have a little terminal that says Z. Okay. So once you remove those resistors and put these in, now you're stuck at full intensity. You didn't change anything yet, except now everything's full intensity. So let me get rid of these papers. So Z is now an on and off signal, nothing in between. Okay. So what I did is I have 4 AND gates. So I'm going to draw that short, 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 and we're going to do long, 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 long. Okay, so what I'm going to do is, let me go back to where I put that piece of paper. What you want to do is, this was, where am I at? Yeah. This, now we're going to connect this, we're going to call this red on this side. Since you're going to attach a wire to this side, and since it's on this side, it's isolated from being shorted out with the rest. It's on this side of the diode. Electricity can only flow in one direction with a diode. So we're going to call this red. We're going to call this green. We're going to call this blue. And we're going to call this white. And I'm going to come back to why we're going to call this white in a minute. Okay, so these are all isolated from each other on this side. But once you get to this side, they're all shorted together. Does that make sense? So we're going to connect those red, green, blue, and white wires to our AND gates. Red, green, blue, white. Okay? And these, on this side, are all going to be shorted together. That's going to go to Z. Does that make sense? So, and if you don't know what an AND gate means is, you have 2 inputs in our situation, and these AND gates we're using. By the way, the chip I went with was the 74 LS08. The chip we're using, if this input and this input are both 1s, then your output will be a 1. Does that make sense? So, if there is anything happening, this will energize all the gates. And then and then which one is happening, it'll say red, green, or blue, or a combination, or so on. Okay? So, after these gates, I have them going to resistors. Now these resistors are 300 ohm resistors. 300 ohm. Okay? Now, then I'm going to go put another resistor. Why 2 in a row? I'll tell you in a minute. And those are going to be 2 kilo ohm. Okay, these are 2K. And what we're building here is a resistor voltage divider circuit. Now, what that means is, let's say you have a 1 ohm resistor here and a 1 ohm resistor here, and they're both connected. If you run 5 volts through them, if you measure at the center point, you get half the voltage. So what we're doing is we're dividing the voltage with these resistors. Okay. Now, so let's go over here. Oh, by the way, these are all going to be shorted together, and this is going to go to ground. That makes sense? Because this is a voltage, and these are being grounded out through here. Now, red, we're going to have extend out to here. Green is going to extend out to here. Blue is going to extend out to here. Now, at this point, red, green, and blue, excuse my terrible drawing, are going to go directly to the monitor. But there's one more thing we need to add. Okay? So I'm going to make this long, just a little in between there. What we're going to add is more diodes. These are also 1N4148 switching diodes. Okay? And these will all be connected together right here. Now, our white, whoops, I didn't mean to draw this right here, sorry. Okay, what our white bit is going to do is come directly out of here. Forget all this crap, I don't know why I drew that. Okay, and have that connect directly to this. Okay, now, so we have red, green, and blue. These three colors are going to connect directly to the monitor. Okay. Now, let me explain what the white bit does. This white bit is actually going to act as sort of a color palette switch, so to say. Okay. So we have our zeros and ones, which later on I'll show you the software side, because thanks to Samuli, the genius of Samuli, my buddy that helped me with this, he understands. You see, I was talking to him and I said, hey, you know, I'm going to do another color mod and whatever, and I says, boy, I sure wish I could figure out how to change the bits around to select the colors I want. It says, because it's going to be a very complicated hardware mod. But if I only could change the bits around, and he just says, oh, well, I can do that. So that you can. So Samuli, he wrote a little program that actually allows you to select the bits and tell them which color you want them to be. So I'm going to get into that in a minute here, but let me finish explaining the hardware side. Okay, so if now keep in mind these are bits. Okay, these are 4 physical wires on the board, and the program can, when you mess with the program, you can say when you want those 4 physical wires to be on or off. Okay. Now, normally they were in a certain order that matched the resistor DAC, but I just disabled the resistor DAC. Okay, so if this bit is a 1, then red will be a 1. But let's say you want pink. Well, you can't get pink with just red, green, and blue. Not very well, at least. It would be a little more complicated circuit. So especially if you're going to go on and off, and that's all you got, nothing in between. Okay, so what this does is, what white does is, it'll turn all red, green, and blue on halfway-ish. Okay, about halfway, and so in other words, red plus white will be pink. So if you're to look at the code, it'd be 1001, and that's how you're going to get pink. Well, let's say you have blue, and you want light blue. Well, that would be 0011. And these things you can change in the program later on. Okay. Now, there's also some things that Samuli did, which is really amazing. The vector generator reads all these different things. Now, the computer can only do one thing at a time. Okay. At any one time, it's saying, okay, colors. Okay, X position. Y position, instruction, so on. Okay, it can only do one thing at a time. Okay, so and when it does something, it sends out a group of wires with zeros and ones. So does that make sense? I'm trying to keep this as simple as possible. I'm hoping I don't sound crazy. So let me show you what the actual board looks like. This is. By the way, I want to show you how to do this on a original OG Asteroids board. But the board I did this to is a bootleg Asteroids board. Thank you, Sasha. Sasha sent this into me through the mail. Now, as you can see, right here are my diodes. Now, yes, it's a really shit solder job, I know. The reason why is because I didn't want to open up the board and I was lazy. I didn't want to separate the card cage because I didn't want to do all the work. These are the 3 diodes. Let me zoom in. These are the 3 diodes I'm talking about. Here's the 3 300 ohm resistors, and over here are the 3 2K resistors. Alright, and I color coded the wires: red, green, blue, white. Okay, does that make sense? So let me plug it in, and oh, by the way, the monitor that I'm using. And one cool thing about this is I attached a color transformer power block on the bottom of the cabinet, and this is going to plug into the original unaltered Asteroids harness. And the way I did that was I had this harness that came out of somebody converted a Tempest to a what's it called, heavy barrel, and so I got some of the guts out of it that weren't being used anymore. But anyways, I'm connecting my X and Y. There's actually terminals on the on an Asteroids PCB. This is a bootleg, but this is the same schematic. Okay, there are terminals on this PCB that say X and Y and so on. And I connected my red, green, and blue to this homemade circuit board here. But anyways, so this will plug directly into the monitor. None of the original harness has been altered in any way. So let me plug this into the machine and let me show you what color Asteroids look like. You know, as soon as I turn the camera off, I realized that there's an error in my schematic, and I want to clear it up before any of you guys decide to possibly build this yourself. Now, the thing I made here does work, and I'm going to show you in a minute. But it could be hard on your chip, and the reason why is, let's say your blue bit is off, okay, and then your white bit is on. What's going to happen is it's going to send a 1 through here. It's going to send voltage through here, and it's going to fight the this output of this AND gate. So what you could do is, and what I'm going to end up doing, is add a diode here, here, and here. Okay. That way, there's no possible way that any other gates are fighting each other. Even if it's through a 300 ohm resistor, it's still gonna fight. So, and you know what? This will work at just how I'm showing it to you, but you may be able to actually forget these resistors too if you really wanted to. You probably could, actually. But okay, so let's plug this thing in and let's see what it looks like. Oh, by the way, the monitor I'm using was from a last video or the video before, where I converted a black and white monitor into a color vector monitor. So that's the monitor we're using. But all right, let's get started. Okay, as you can see, I just kind of had the board sitting there for now. This is just temporary, not 100% built yet. Here's the original Atari power brick. And over here I have a color power brick. And I could have eliminated the original power brick and went with a color brick instead, but I didn't want to mess anything up. This way, none of the original harness is damaged in any way possible, and I could actually plug, and I still have the existing monitor plug, and I could plug in a black and white monitor, you know, to work in tandem with the color monitor if I wanted to. I mean, it's all original. Also, you can see I used a Vision Pro deflection board from a CRT. Using that for high voltage. Anyway, that's a whole other video. But let me show you the front of the cabinet. By the way, this cabinet's filthy. I haven't done anything with it yet. Now this, I changed the graphics around. Do you see anything different? First off, there's no rocks. There's no rocks at all. Let me turn it, you know what? Let me start a game. Oh, by the way, another thing I need to mention is this game board has no sound. That's a whole other issue, unrelated. I will fix that later. But I just want to show you the hacks. See, remember how Samueli, he made the program so I can easily change out the bits that control the intensity? Well, because of that program, I was also able to change the bits that control the vectors. So very cool. So let me start a game. I got this thing right in front of me. see, that's red, green, blue. Now, I don't know if you can see this or not, but you really can't tell on the camera. There are multiple colors in that circle I made. This, if you do the math, if my math is right, there are 12 possible colors that this can display. So you know what? At the end of the video, I'm going to take some pictures because it comes out better with pictures, and because vector monitors are really hard to they're really hard to take a video of, at least with my camera. But the explosions are white. A lot of the things are white. Now, I wasn't able to change everything because the software isn't there yet. Me and Samuel, we have some crazy plans on what we're going to do to this thing. In the future, I'm going to extend how much ROM data this game has, and we are going to put in SpeakJet code and things like that. So that's one reason I'm not too worried about the sound, because I'm going to design a whole new sound circuit for this board. After all, it is a bootleg. Who cares? But in other words, this game's going to have speech when I'm done. But yeah, if you like this kind of stuff, subscribe. Why aren't you subscribed yet? All right, have a good one, guys.
Boom shakalaka. Boom shaka, boom shaka, boom shakalaka, boom shakalaka.